Hello, my name is Rick Jericho. I work as a technical account manager for Eccentric Mold and Engineering. Eccentric is an injection molder that specializes in fast turnaround times for prototypes and low quantity production runs. Today, I will be reviewing one way Eccentric works to reduce lead times. The most common obstacles we are facing now are increased lead times for plastic material. Over the past several months, there's been a material shortage causing most material suppliers to be force majeure or first come, first serve, but lately it's even been hard to get a lead time from suppliers. Eccentric stocks the most popular polymers. In many cases, there are multiple options for each part that meet the needs for any given application. Here at Eccentric, we always have at least 40 different resins we keep in stock to reduce lead times. In the following slides, we will review 7 different stocked resins that are commonly used in the medical industry. The following slides will give an idea of the materials we keep in-house to reduce the lead time to manufacture parts. There are several advantages to using plastics in the medical industry. The first thing that comes to mind for myself is versatility. Plastics can be used in many different applications, either as one-use items or instruments and devices that can be in service for years. Some of the common applications are products like bedpans, sterile bags and containers, catheters, pill casing, implants, joint replacements, safety equipment, syringes, surgical instruments, and tubing. Another advantage is sterilization. Plastics are used for many one-use items, but for the ones that are not, there are plastics that can be sterilized in multiple ways. Some plastics have even been designed to help kill and repel bacteria, mold, fungi, and viruses. These materials are commonly used for surgical instruments to help prevent the spread of diseases and infection. Lately, over the past several years, plastic materials have been used quite a bit in 3D printing. These have been used as joint replacements and implants. The cost of plastics: it is easy for plastics to be mass produced. Once the design and development has been completed, products that were once made of metal and glass have been replaced by more durable, cost-effective plastics. Safety of plastics. When plastics are properly designed and the correct material has been chosen, this can help improve wear resistance. Plastics can be more durable, shatterproof, and provide a better alternative to shipping. While many medical products are one-use items, many can be used over and over again, and then recycled when their life cycle is over. First material we're going to talk about is DuPont Nylon. This is a 6/6 nylon that is commonly used in medical applications that require strength, toughness, and stiffness. Nylon can be seen being used in applications where 2 or more parts are rubbing against each other due to its wear resistance. Some of the common applications are inhalation and injection gears and actuators. This material is used when toughness is needed with a good chemical resistance. While there are many benefits to nylon, there are some disadvantages when processing the material. Nylon tends to absorb moisture, so special consideration is needed when prepping the material for processing. Nylon also has a greater shrink rate than most amorphous materials, so tooling engineers should take this into account when designing the molds to prevent warpage and part distortion. Covestro-Mechlon is a polycarbonate material that is one of the most commonly used and tested materials in the medical industry. Polycarbonate can be transparent in its natural form. It has good impact resistance. It can be used with both lipid and gamma-resistant products. Products made with this can be sterilized by gamma, ETO, E-beam, and steam. This material tends to have a weak chemical resistance and may have discoloration when exposed to UV in some sterilization methods. Some of the common applications for this material are IV sets, connectors, surgical instruments, trocars, sight glass, and lenses. Because of its wide range of physical properties with superior strength, rigidity, and toughness, this material is used a lot when replacing parts that were originally made out of glass or metal. While polycarbonate has been in use for over 50 years and has a good safety track record, another thing to take into account with polycarbonate is that it is not BPA free. While there are only very low residual levels, this still needs to be evaluated when considering this material. ABS is a very common material used in medical devices because of its excellent balance in properties. The material is opaque in appearance, has very good chemical resistance, has good impact strength, and is known for its durability and toughness. It is easy to process and bonds well to other components. ABS is able to be used in all of our processes from injection molding, CNC, and 3D printing. When considering this material, we should evaluate its exposure to high temperature and review the application's requirement for impact resistance. This material is commonly used to make caps, covers, internal components, syringe plungers, valves, face masks, and test tube racks. With both PC and ABS, there are many advantages with some disadvantages. For Covestra Bay Blend, we blend both PC and ABS to get a lot of the advantages of both. Unlike pure PC, this material is opaque. This material is often used with colorants and different textures. It has good mechanical and thermal properties, giving it good rigidity and dimensional stability. This material can be sterilized with gamma, E-beam, and ETO. It shares the same strengths and weaknesses of PC. It's compatible with aggressive cleaners and chemicals, but has a poor resistance to UV and some sterilization processes. Some of the common applications for this PC-ABS blend are covers, monitors, handles, caps, battery enclosures, access panel, and control knobs. Next material is PMMA, or acrylic. This material is transparent. It is BPA-free. It is easily processed and has good chemical resistance. Acrylic is very rigid, giving it low impact strength. Acrylic is commonly mixed with PC to increase its durability. Unlike polycarbonate that is also transparent, PMMA is not affected by UV exposure. When considering this material, evaluate the product's exposure to high temperature and review the requirements for poor impact resistance. This material alone is used for lenses, blood collection and separation cassettes, valves, stopcocks, filters, and incubators. Medical grade polypropylene is very common resin because it is easy to process, has good strength and stiffness. Some grades of polypro can be sterilized, but many of the products made with this are for single use. Polypropylene has good chemical and bacterial resistance. When considering this material, temperature exposure and requirements for strength should be considered. This resin is commonly used to make vials, collection cups, lids, funnels, diagnostic kits, syringe barrels, and plungers, and pharmaceutical containers. The most common uses for this material are disposable syringes. Persiflex TPE is a softer material that is commonly overmolded over another stiffer material to give it a softer feel. This can be sterilized with autoclave, radiation, and ETO. It has a good ambient and elevated compression set properties. TPE softness makes it more difficult to eject, so that needs to be considered when making a part, and testing needs to be done to make sure it can be bonded to other materials. This material is commonly used as seals, gaskets, plungers, soft touch overmolds for grips, weld pads, and stoppers. There are food contact grades of TPEs being used for baby bottles and spoons. TPEs are being used more to create seals that were traditionally made out of thermoset rubbers. Processing TPE material is more efficient, it uses less energy, and can be produced faster than thermoset rubbers. Because TPEs remain flexible at low temperatures, this material is starting to be used to replace PVC, latex, and silicone rubber in the medical industry. These are just some of the common materials that Eccentric stores in-house that are readily available to mold injection molded parts. Eccentric serves as experts in design to produce quick-turn products through injection molding, CNC machining, rapid prototyping, and 3D printing services in the industries of medical, aerospace, defense, automotive, consumer, healthcare, and electronics industries. Eccentric has 2 manufacturing facilities in Michigan around the Detroit area. All molds are designed, built, and run in the USA with a lifetime guarantee on production molds. We pride ourselves on helping customers to solve simple to complex challenges. While we always have 40+ materials in stock, we have access to thousands of engineering grade materials through our suppliers. Injection molds can be built in as little as 5 business days. Eccentric specializes in prototypes and small production runs for both simple and complex tooling, overmolding, internal and external threads and undercuts, in a single cavity and multi-cavity tools up to a shot size of 1.5 pounds. CNC machine parts can be made in as little as 5 business days for part runs, anywhere from 1 piece to 100 to a couple hundred in either metal or plastic materials. Rapid prototyping can be done in as little as 3 days through cast urethane or multiple 3D printing processes. With these manufacturing capabilities, there are almost no geometric limits that we cannot design and manufacture with one of our available processes. Thank you for your time. If anyone has any questions about the materials or our services, please reach out to Eccentric, and one of our technical account managers will be happy to assist. Thank you and have a good day.